What do we think? Do that. Okay. So can you guys see code at the current time? That
yeah, you're moving around. I can see you fine now.
Yep. Okay. Cool. Well, then we'll go with the less fancy version. Sorry for doing things that boggle our friend Zoom here. All right. So in C# 9, we hit the first time where we have introduced a new type of thing. Whereas we know about enums, we know about classes, right? We now have a concept called a record. So this could have been a class, was a class, but we've come in and said, hey, this is a record. And the moment I do that, I have declared a thing that, to be clear, is an object. Okay? We have not created a new thing that things become. We've just created, a class is a template by which we make an object, right? It is, when I teach new developers, I always use the cookie cutter example. The class is the cookie cutter. The object is the cookie. And in this case, we're creating a new type of cookie cutter. We're still making cookies at the end of the day. And this, but this concept of a record has some fun things about it. So I can just do record and then write this syntax here. You'll note this is a set of parentheses. It's not a set of square brackets or curly brackets. And so what we've actually done here is we have basically written the constructor directly beside the class name. And we've said, we want to be able to construct this. And by writing it at this location, we are also informing C# that we want it to automatically create properties for this set of constructor parameters. So we're going to jump back over here to our friend Hello World. I'm just going to put a console.readline down at the bottom of all of this and simply say execution is done. Right down here. All right, so let's go ahead and create person 1, and this will be me. So we're just going to new a person. Okay, and what person are we newing? We need to add a reference to the namespace. We're going to come in here, and then it's like, okay, you need a first name and a last name. Well, no problem. That's Tim and Rayburn in this case, right? And I have a person 1. And then I can create a person 2, right? And we'll go ahead and pick on David. And so this will be David Penton, right? Done like that. All right. And so now I have 2 person objects that were created out of records. So fun things that happen from there. Let's go ahead and look at what we can do with that, right? So I can come to P1 and you can see that I have a first name here, but something that I want to bring to your attention is that if you look at the description of this first name here, it's a string person.firstname get and then init, not set like you would be used to. So this is the concept of a property whose value can only be set during the initialization process. So basically, it can be set during construction and nothing else. Okay? So we can come in here and I could write out the first name, right? But if I go to in here, reset the first name to Timothy, right? I will be told, no luck, init only property or index or person.first name can only be assigned in an object initializer or on the this or base in an instance constructor or an init accessor. So this is a saying, this is read only at this point. You've given me a value. You cannot modify it. And that is a truth about records as a whole, is records are representing state that should not be modified, okay? And so They are very powerful, very useful for that. And added bonus, the C# compiler can do a bunch of cool things for us when it knows that we're not going to muck with those values. All right. So if I were to go and execute this right now and show you what we've got going on, right, I get a Tim right here. Execution is done, but I output the first name. But what if I didn't output first name? What if I just took this object and said, hey, object, just console.writeLine the object. So I'm going to put Mr. Eric Sowell on the spot and go, Eric, when I ask C# to do this into class, what's going to happen?
Well, if it's a class, you're just basically going to get system.object, if I recall correctly.
Right. You're going to get the type name, actually, is what you would get out, right? It would run system.object would go run and go, what's my type name? That's all I can possibly know. So that's what I'll tell you. Okay. But if we run this now, we'll instead get that, which is what the type is, right? And what its two property values are, because it knows about the property values. Okay. So that in and of itself, an overridden toString that is more meaningful, more useful, right, is already a reason that's like, okay, records are doing something cool for us. But you want to know something? Records are doing something even cooler for us. So if we then, now that we've seen we can get that toString, that's interesting. Let's go ahead and let's create a person 3 at this point, right? And I'm going to create person 3. And I'm going to make it a new person who is also David Penton. Okay.
So Tim, since you're calling me here,
Yep.
I will say there's a question in the chat.
Yep.
Amir would like to know, is a record type a value type or a reference type?
So the answer is it is a class. It is a reference type. Okay. But the since it doesn't want to be modified, right? It starts to feel like a value type, but it is a reference type. Okay.
I have a follow-up question from this code sample.
Yep.
I see that Penton is underlined, so I need you to tell me that he is a compiler error.
Unfortunately, he is not. What he is a misspelled word according to CodeRush. So my CodeRush knows my name. My CodeRush does not know David's name, which is probably all for the better. So
I would just say that just about sums it up for me.
So I'm going to go ahead and run this at this point and dump person 2 and person 3 out. And we will see they both say that they are David Penton. Okay. Now, the next thing I'm going to do is going to be super fun. We're going to do a console write line of the P2 equals P3. Okay. So we've got two objects, identical properties. We're passing one to the other and going, are these equal? Okay. Let's stress, in the object world, these are not the same object. And so the answer is no, these are not equal. Okay. This is gospel truth that you can count on in an object world. On the other hand, in a record-based world, why, yes, those are equal. Okay. So the compiler for a record has also overridden the equals comparator to make sure that it is considering inequality all of the properties that you have put on the record. Okay. So this suddenly starts getting very interesting. Now, if you're like me and are addicted to certain data types in .NET, the very natural next step is to come in and go, oh, they're equal? That's awesome. do they have the same hash code? And the answer to do they have the same hash code is yes, they do. Okay. Now, having the same hash code opens up a lot of interesting options, because that means that, for instance, if you create a dictionary, regardless of whether or not you're passing P2 or P3, you are now going to reference the same location in that dictionary. Okay. Because dictionaries use hash code to keep all their indexing straight underneath the covers. All right. So we get a lot of interesting power that starts deriving out here. So the final things, so there are two more things I need to show you about records to really begin to show you, just from a code concept, why these are awesome, why you care for this C# feature. Okay. The first of those cool new features is a cloning concept. Now, I don't know about you guys. I have written some ridiculously large data models before, right? You know, data transfer objects with 150 properties on them. Okay. And it's easy to sit around in an ivory tower, oh, I like functional programming kind of world, and go, oh, we should have immutable objects. But what if I come into a data object and I want to change one property, and in all other ways I want it to be identical to the previous object? Okay. If I want to do that, and there are 150 properties, that becomes very tedious code to write. It also is the reason why most people wind up talking about AutoMapper, okay? Because of the fact that they're like, no, copying property to property, that's tedious, boring. I don't want to write it. Give me an open source project to be able to do that. Well, it winds up that in C#9 for records, we get a great way of dealing with this. So we're going to create a P4, and we are going to say that P4 is going to be P3 with a last name of Rayburn. So if we've successfully completed the adoption of David into the Rayburn family at this point, right? We were tired of his last name triggering my spell check problem, okay? And so now I have a new P4 object, and it has all the previous properties except for the fact that it is now has a changed last name. And it was based on P3, but if I go run this, you will see it definitely does not have P3's hash code, but it is first name David, last name Rayburn. Now in this example, I saved myself typing one property, but the reality is that would have saved me typing any large number of properties. If that were 200, 300, 1,000 properties, all of that would no longer matter, because I was able to go, I am that other record with this one mutation, this one change that modifies the state of this object. So that in and of itself, we're approaching the pretty darn cool line. One last thing to show off, and that is this. Sometimes we want to not deal with the record, but to deal with the properties within the record, and we want to do so quickly. Okay? So it winds up, we can now write this. This is the one that's going to get all the questions, so I'm ready for it. And L name. Okay, so let's go ahead and run it, and then I'll answer the how in the God's green earth could that possibly work. Okay, So I have just executed this line of code over here where I went var, and I put a set of parentheses, and I went f name, comma, l name. And then I just assigned that assignment variable to one thing. So I said two variables, but now I've assigned it to one thing. That one thing is the record that we created that had David Rayburn. And when I do so, suddenly I have David in the first one and Rayburn in the second one. Okay. So I have done what is called deconstruction of this object. Okay. So let's pause there. There was a whole lot of record coolness there. What questions might we have?
All right, 3. With regards to equality, what if one of the constructor properties is something like a list of T?
I'm going to table that one, but that's the next subject we're about to get into. Okay.
Cool. Is there a collection record type?
There is not.
And do record types cast to named tuples?
Do they cast named tuples? Now that is that an Amir question? That feels like an Amir question.
Might be.
Yeah, might be. Okay. So I believe the answer on the tuples is yes, but let's go put that to the test, right? So if I have a tuple of string, right, that I am going to name my tupes. And I say, hey, I would like to assign P4 to that. I am going to get a cannot implicitly do that conversion. Now, next question is if I tuple of string here and go to the params, right? And then can I do that? And will it figure it out? And the answer to that is also no. So the answer on the does it cast nicely to a tuple is no, not without work. Okay.
All right, cool. 4th question from Gautam. With records and static functions, do I even need to think of object-oriented programming in C#?
So I think the answer to that is we are beginning a journey that we've been on, or we're continuing a journey we've been on since C#3, literally since the first time I gave one of these skills update talks so many years ago to a North Dallas audience, by the way. When I did this talk, which is we are seeing more and more and more functional features enter into C#. And I absolutely believe that it is Microsoft's intention to view C# as a language that can either be developed functionally or be developed in an object-oriented fashion. And then I would tell you it comes to what is the best option for the problem space you're trying to work on. So I'm giving you the perfect consultant answer, which is it depends. Okay. I think that there certainly, if you're doing pieces, the canonical functional example is large mathematic applications, and financial applications where it makes a great deal of sense to be working in a functional world, then by all means work in a functional world. But I think instead what we're just seeing is C# adopting an ability to do this in meaningful ways. I will tell you that I, for my current clients, work in a world where we are developing in an object-oriented fashion, and yet there are aspects of records that have become absolutely critical to, amongst other things, how we unit test. Okay, there are some fascinating things since a few years back. Amir could put me and my buddy Devlin in a headlock, both at the same time, doesn't matter how tall we are, and went and convinced us that shipping the stub and thinking about unit testing as a first-class citizen of an open source library or of any library that you're maintaining was very important. Definitely made it through our thick skulls eventually. We totally didn't argue with him for 6 months. And when we were done with that, one of the pieces that has flown out of that for me is thinking about that always, even when we're developing internal libraries. And so I happen to be a fan of the query object pattern, an object that specifies the structure of a query that I want to execute, say, against a database. And have maintained an open source project for years that helps implement that in the entity framework world. But being able to look at a query object that was generated out of code and then have a test framework go, I expect the query object to look exactly like this. And when it does, this is the return set I want you to give back, right? Becomes remarkably convenient. And so we wound up using all of our query objects in my current client are using records just to get the equality and hash code changes that came along with it. So, there is like any brand new bright shiny tool. There's no clear. Yes, obviously, all things should be functional, despite what my F# friends think about the world. But it is definitely a useful tool. Because that's 5 minutes more than you wanted on that, most likely. All right. Any other questions, or should I go on to how do we deal with many things in the world of records?
I think you can go on.
All right. So what happens when I have a list of T or the equivalent? So let's go ahead and create our friend bad record over here. And bad record is going to have a name, and then it is going to have a list of int, which is scores, okay, that gets passed in. And we have to bring in the necessary using namespace over here. And so we'll bring in collections generic to make that work. And then we'll flip back over here. So we're going to put down a big bold line as we transition into this thing, just so that we have some division in our work. All right. So now I'm going to create an instance of bad record. Okay. And inside of that, I am going to say Rangers. And I am then going to go ahead and do a new list of T. We will go ahead and get rid of all this giant muckety-muck type qualifier. And inside that list of T, I'm simply going to do the first 5 integers like so. And life would seem to be perfectly reasonable if I come in and let's do a console write line of our friend bad, right? If I were to run this, nothing intrinsically like, oh my gosh, what's going on? We have a collection of generic list of T, right? With the T being in int 32. I guess I can get behind that. It's a little bit of a weird dump, but we can do it. All right. But now we get into the challenges. Let's go ahead and create bad2. And now we will ask bad if it is equal to bad2. And we will run again. And the answer is it is not equal. Now, this would seem odd. Didn't we just initialize these two as the same thing? And the answer is sort of. Okay. Each of them has a different reference type that they're using, though. Okay, so we can fix that. Let's grab this. Just put in scores here. Let's create a variable named scores, right? Set it equal into that instance. Then we can come back here. Also make this scores. So now we have two records, each referencing the same instance, and we go ahead and kick this off. And now, see, now everything's better. We now get a true. Everything is not better. The system is lying to you. Okay. So all we have done is taken as a member the pointer to the list. That is all that is being considered. The reason why the first example was false for equality is because we made two completely different objects. They had two completely different pointers. Because they had two completely different pointers, they had two completely different memory addresses. Their values were different. It went to compare the values of the pointers and said these objects are not the same because they have the same name, but they have different scores. Okay? That is not to say that we have properly checked the values underneath there. Okay? And furthermore, it is worthy of note that if I were to come in here, take this, take the scores, tell it that I want to sum the scores, okay, using LINQ to create a sum of all the scores in that collection, right? And then I were to console right line bad scores sum here again, except this should be bad too. So if we run this, we're going to get 15 out of both, okay? Now, if I come to scores and I add a 6 to that scores list that I gave, and then we run the sums again, then at this point, the second set of sums is 21, because that list did not become immutable, did not become something that we could not change or become a record type just because of the fact that I included it as a record, okay? So this really inclusion of other reference types which are not records themselves is problematic at the current time. You can't do it in this space, okay? And since undoubtedly it's going to come up, there is not a record-based structure that I am aware of that reports as a record, handles properly, etc., that truly makes this all better. There are some things that are less bad, though. And so we're going to come in here. So we're going to establish a integer array here that we can pass as a params. We'll name it with a lowercase s because I did on the previous one. All right. So we'll go through, work with our less bad variant now. Okay. And go, I want to be able to grab these two things again, except now we're going to do the less bad record. And we are going to simply pass 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. And these will be LBAD and LBAD2. All right. So when we do this, what we wind up with is obviously LBAD has a scores, and that scores is an integer array. Okay. Now, when we do that, if I come in and go, all right, console, you want to know something? I'm tired of writing console a bunch of times. Let's show off a really cool feature using static system.console. So this is a feature from a previous version of C# that you probably didn't pay attention to, but when it came out. But it lets you name a class, and then all of the methods on that class that are static are now simply addressable without using the, that's not what I wanted to do, without using the class name. So let's go ahead and let that run. Okay. So I can now stop being in the habit of typing console all the time and just go down to writing write line all the time. It'll make my life a little bit easier. We'll clean up this previous code to be a little bit more terse. And okay. Probably should have just done this with a cert find and replace, but that's besides the point.
We have a comment. I'd like to hear what you say here. Sean says, I presume to make a reference type such as list of T a first class part of record, the constructor should take in an I read only list of T.
So yeah, so the read only and the read only T's and the immutable T's are now unfortunately just a giant pile of showing their age in the framework because of the fact that they didn't do the hard work to properly override equals and to properly override get hash code on those classes when they wrote them. And because of that, they weren't looking at what was expected internally. They created a situation where we can't use them and get the expected behavior because of the fact that the record itself is basically, it just cares about the one type I've told it about. And so if that one type doesn't properly handle equality and hash code itself for all types it hides, then we get into this tree of problems where we start wandering off and not being able to find ourselves into a good solution. Okay. So I'm going to pick up where we left off now that I'm done boring everybody with the update. Apologies for that. We're just going to come in and take this less bad and less bad too and ask, are they equal? Okay. And we are going to get, no, they are not equal. This is once again because of the fact that even an array originally, right, was an array object, and its array's behavior for equality did not care about how many members it had. It cared about its memory address. That's all it cared about. And so to really solve this, what we probably need to have is a record-based array, a record-based array, okay, to be able to handle this. And unfortunately, not in the list of things we got with C# 9. So we can do trees of things, and a record can have another record as its child, and everything is good. But the moment you go record, object, problem. Okay. And so the only thing that we can include are things that already have properly overridden equality, which is basically the value types and string. So any other questions there?
None at the moment.
Cool. All right. So this capability of writing records is fun, but the terse syntax gets a little bit crazy, because if I wanted the record with 150 objects or with 150 properties, that one line constructor syntax is going to get a little bit old. Okay. So we have alternative options, because everybody should be, coding in, 24-point font like I am at the current time. And so if we wanted to create a record that was large record object or large record, right? We can come in and simply create the large record and then forego the constructor syntax beside its name and simply go into it like it would be a class declaration. Okay. And when we do that, we can then use things like, all right, let's have a first name, right? and we can simply write our properties like this, get and init. All right. And then if we come in here and do the same for last name, okay, we would have that. And we could do this for a very large number of potential properties. So, yeah, let's do an int of age, right? And set it as get and init, right? And then let's just be ridiculous about this example, put in a whole bunch of ages, and then come in and simply create age 0, 1, 2, 3, 4, 5, 6, 7, and 8. I'm feeling like I came short of the important one. So let's go ahead and add 9, and now we're there. Okay. So I've just created a whole bunch of additional properties. Now, in here, I have not declared a constructor on any of these, right? We simply have said, here is a whole bunch of properties. Please have these properties available on this record. What does that mean when I go to use it? Well, the answer is, becomes kind of fun, right? Because of the fact that we are going to now come in and new up our large record. And our large record is perfectly happy to let us pass a basic constructor and not set anything. But the moment I do that, the age 0 is no longer settable, right? Because we're past construction, okay? Now, to deal with this, it is important to know about a C#3 feature that nobody realized was quite the thing it was at the time, which is the concept of object initialization being technically part of construction, okay? And so you can then come in here, put a set of curly braces afterwards, and say the first name is going to be Tim, the last name is going to be Rayburn, and then the age 0 is going to be 40, okay? And then we'll come in here, create a whole bunch of these, right? And create 41. Okay. Get rid of the ones we don't need. And then likewise change their values to 41, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. I'm actually going to leave off 9 to demonstrate a thing here in a moment. So I'm actually going to not populate that value. When I do that, we're going to see several things, right? If I right line this, we'll see this in a moment. We'll actually get the values, okay? And if I come in here and I do a right line and I say I want large age 5, I will also get the 5th age out of that object, okay? But if I right line and say I want large age 9, we're going to wind up with a value in there that might seem a little counterintuitive. So we've come in, when we dump the whole object, we get the full record toString like you would expect. It enumerates all of the properties out on the toString, just like we've said. If I get the 5th age 45 comes out, we're good. If I go after age 9 gets set to the value of 0. So this is, of course, to me, but perhaps completely crazily to you, because of the fact that we didn't tell C# what to do with it. It's a value type, and as such, it can't be null. So what it became was the default for that value type. So in this case, the default value for an integer is 0. If we didn't tell it otherwise, that's what C# is going to assign it. And so that's what it got assigned in this case. Even though we didn't give an explicit 0, we simply left it out of the object initializer. Okay. All right.
Two things, Tim.
Yes.
One, Sean wonders out loud, I wonder if this is possible, talking about the initializer syntax, due to the fact that the scope is still a construction scope and init is available during construction.
Yes, that is exactly what is going on here, is because this object initializer is still considered within the scope of construction of this object, okay, we are able to assign these values at that point, right? And if they were settable things, it would be different. We could set them at any point. But since they're init things, we can only do them during construction scope. And so our choices are either have an explicit constructor that lets us build what we want, or use an object initializer to accomplish what we want. Okay.
Yeah. Amir is also wondering if nullable of t, like nullable of int, will break equality.
That is an interesting question. I don't know the answer to that. Shall we try it out? It seems like a thing we should just go try out.
I think we should try it out.
Yeah. All right. So the question then becomes likely addressable first by simply saying, if I have a nullable of int, right, that is n1, that we assign a value of 47, okay, and I have a nullable of int called n2, and its value is 47 as well. The real question is, are those the same according to equality? And since I don't know, we'll just ask them. So we will go and perform that equality comparison on nullability. And the answer is that yes, we get those two things are equals true, okay? Which is an excellent sign that we're going in the same direction and that this will work just fine and that the nullable of t will not break things. We will do one last quick check. We'll double check the hash codes while we're here, okay? And we'll come in and say, let's get the hash codes for n1 and n2. And if those are also in alignment, and they are because they are literally the integer values in this case, then yes, we are absolutely in a good state. And because somebody is being a pessimist at home, because if nothing else, my brain is being a pessimist at home, I'm going to quickly do nullable of int n3, which will be a null, and nullable n4, which will be a null, okay? And then we'll ask this question between n3 and n4, and we'll continue this line for n3 and n4 as well, and see what we get. Okay, and we get a 0 out of the hash code, and still true for the equality. So we're good to go there, though there's probably a really sharp corner that to be discovered there, which is what that does, right? So yeah, so that works, but proceed with caution, because a nullable that's null and a nullable that's 0 both show up with the same hash code. So that's a sharp corner that could bite you in behavior land. But you should largely be okay without running into problems there. Does that make sense to everybody? See what I did there?
Yes, no questions.
Okay. All right. So now that we've seen these fancy dancy records, what do we do with these fancy dancy records? Okay. The other big aspect that we have gotten out of our C#9 that is relevant to records as a whole is the concept of pattern matching. Okay. And I will warn you in advance, if you are one of those zealotous people who are C# dev and believe that anything that looks even remotely like the introduction of words, not symbols, into your source code is a bad thing, then there are bad things in your future, because here they come. All right. So we're going to go over and write ourselves in over here a new class. Okay. So we're going to write an extension method that is a Boolean, returns a Boolean, okay, public static Boolean called isValidAge, okay? And so this is meant to examine an integer, which we'll call age, okay? And we're just trying to determine, is this even a reasonable age for a human being? It is a simple helper method to accomplish that. Okay, we're actually going to even forego the land of curly braces. We live in a land where there are expression-bodied methods exist. So we're just going to go ahead and do a little lambda symbol here, go into an expression body, and we are going to simply say age is greater than 1 and less. That's Code Rush being helpful when it shouldn't be, and less than 150. Okay, and we're simply performing this as a comparison. Why are you mad? Ah,
Probably mad because I can be 0 years of age.
can you really?
I mean,
how are you 0 years of age, sir?
I mean, I could be. I mean, I could be just like just born. It rounds down, right? I don't know.
It's okay. We will accept that silly people might round down and make it 0 to greater 0 or well, actually, then in that case, you actually want greater than or equal to 0, which is that way. Greater than or equal to 0 and less than 150. Okay, and so having written this, and I had to put it in a class, that's why it was mad at me. This method, this is what we refer to as a pattern. Okay, you'll note we didn't say age greater than or equal to 0 and age less than 150. Okay, which is how we might normally have written such a pattern. Okay, we simply wrote the pattern in this structure. Okay, where we're using the actual is and the actual word and. Okay, and it simply automatically assumes that it knows what we're talking about in this particular case and carries it forward for us. All right. Now, that ability to express a pattern like this actually has some interesting ramifications, right? So if I were to come back over here, we had our large object we initialized above, right? So if I were to come in and go, hey, large, let's grab age 0. And in here, I can ask, is that a valid age? Okay. And then I'll simply right line that out. And of course, we're going to get a true for this because that's a 40-something value at the current time. So we get a true out of this. But that is not the end all be all of places that we can use patterns. There also exists a capability to use these in switch-like structures to be able to go and switch over a value. All right. So we are going to go ahead and write no, let's not delete that. Let's come over here. So static or public static string, guess the age. Okay. We are going to take in a large record in here that we will name record. Okay. And then once we're inside this, we're actually going to say record dot age 0 and then switch. Okay. And then we're going to go into a code block. Now, this is a switch expression, which is different than a switch statement. Switch statements start with switch, go into a set of parentheses, just have a thing you're evaluating. Okay. This is thing you're evaluating, the word switch, and then a block of things which can include patterns. Okay. And so now we can start coming in here and write in our write in any sort of evaluative case that we want. Use a lambda to then transition, and in this case, we have told it that this switch is a statement. It is in a expression bodied method, so it expects that we're returning that string directly out of here. So nothing cool to see here becomes the value that we put in to our switch statement. We put a semicolon at the end of all of this, and we are good to go. And it's now, okay, got it. It's basically telling me you can't use large record because large record isn't public, but that helper method is. Okay, so now I could come over here, do a write line, say large, and hey, words are important. We should put a this here so that it actually shows up in this extension method. Okay, so we can do this. Now come in here and say, guess the age. Okay, and every age, regardless of what value that might be, is going to say, see, nothing cool to see here. Okay, so the actual concepts around pattern matching and switch expressions actually came out of the C# 8 work, okay, to do things. And so what we have right here is the simplest of examples, which was a switch case where we used an underscore to describe a pattern where we don't care what it is, okay? But we could actually come in here and go, you want to know something? We could evaluate the record itself instead of driving to a property before we go into the pattern. And then in here, we can describe a pattern we want. Like, for instance, I want this pattern to match only when age 0 is 40, okay? And then I'm going to put in another pattern, which is when age 9 is 0. We're evaluating completely different things. No value for age 9. Okay? We're evaluating completely different things at this point. Now, for those who are going, wait, Tim, the value you're about to pass in to that switch statement is true for both of those things. And that is correct.
Wait, Tim. Wait,
Yep.
Tim, the value for both of those properties is true of those things.
Yes, see?
Did I do that
Thank you. Thank you, Eric. Thank you. Yes. That's going to be true for both of those things. And this is the answer is that for switch expression, it wants to find one yes. Okay. So if the pattern that we give matches the object that we've given, it's going out because we're just, again, trying to satisfy this string. Okay. And so we are going to come in here and we will see nothing cool to see here in this case. All right. I'm actually going to put one last thing in here, which is default case. Okay. So if we come in here and we run this, we're going to continue to see nothing cool to see here. But if we go back to our demo code and, or pardon me, if we go back here and simply raise that line up one so that the age 9 check is above, then when we run this again, this time we'll say see no value for age 9, okay? And if we wanted to, we could further come in here and do a write line, start doing combos of things, right? Where we do we want large with the following changes. I'm going to need another set of parentheses by the time this is done, with the following changes, and that is that age 0 is about to become 30 and age 9 is about to become 60, okay? And then when I'm done with all of that, I want to guess the age on that object that comes out, okay? Okay, that is CodeRush being silly on those red squigglies, I believe. I've done this demo before. Really, I have. I think this is IntelliSense did me wrong. Yep, IntelliSense did me wrong. All right. So, yes. Yep. Definitely. IntelliSense did me wrong, did me the colon syntax when it wasn't what I wanted. Okay. So, come in here, run this again. And in this case, I've wound up at the default case coming out the bottom because of the fact that I moved it so that we didn't satisfy any of the other cases. Age 30 does not hit, age 60 does not hit for age 9. So we're now in a default case dump out for that switch expression, okay? So there are a bunch of interesting structures and patterns for how we can do and how we can handle patterns in interesting ways. Like I said, these are C#8 features, but they're interesting nonetheless. I'm going to go ahead and leave a comment right here on that is the page at Microsoft that describes all of the possible patterns that you can write around objects effective C#8. And so that will get committed into the source code repository here at the end of the night. So you can just go grab the program CS and grab that link if you want it at that point. Okay. All right. So we've shown you records this evening. We have shown you the ability to do pattern matching, init-only setters. You can use init-only setters in your classes as well. By the way, you don't get the cool equals and hash code work because that only happens for records. But if you have a property whose value you want only set at initialization time, then get init is actively better than get private set, which is what we've been stuck with for years. So I would encourage you to abolish the pattern of writing code that is get private set from your mind and vocabulary and instead transition to get and init. So there are a couple of little, they make your life a little bit easier things that are probably worth mentioning. And I think the only one that really lights me up to the point where I would want to spend some time talking about it is, as you can see, I am a member of the cult of var, okay? I like writing variables that declare their types by simply saying, do the var thing, okay? And I don't have to think about the type because the type is after the equals and all is well and good. Well, one of the things that we've shipped in C#9 is an ability to reverse this opinion, okay? So I'm going to remind you that we had this person object up here at the top. So way down here, right, we're going to go ahead and create somebody else. Let's do Eric this time, okay? So we are going to create person Eric. And then we are going to set person Eric equal to a new, go into an open parens. Please note I get constructor helper at this point, constructor help at this point. And we are going to say Eric cell. Okay. And so this is the same var magic turned around on us, right? This is the compiler going, you've told me what this type is. The type is clear to me as the compiler. And as such, when you tell me new and go into a set of open parentheses, I'll show you the constructors for the type you've already told me of person. Okay? So in the situation where you know that you have already declared the type, or even if in a later point you wanted to set Eric equal to another instance of Eric, even if it's not on the same line, if we know the value, the type of the variable, simply new open paren allows us to do a new one of those at the time, okay? And so this lets us do less typing. I think that if for my use, I can tell you that I don't use this very often, but I do use this now that I've gotten into this, right? Of if I already have a variable and I just want to create a new instance into that, right? And I want to be able to stick a new person in that is Justin Williams, then I can just do that. And voila, I have a new person that is Justin Williams. And it was figured out from the fact that the Eric variable is of the type person.
I'm sorry, I just can't stand for that.
You can't stand for Eric being a person? I understand.
No.
I don't like Eric being the name of Justin Williams.
Okay. Let's see. We're gonna do a rename here and go to something that is true of both of you. Okay.
Critique accepted. Yeah.
Yes. So that gets us to a capability there. So that's the only sort of fit and finish feature that I really think is super cool. I will say, if your particular Jive is writing code generating classes, then C#9 has a lot of additional cool things for you that I'm not going to go over because I'm not that geek. Okay, but if you're into writing extensions to the Roslyn compiler that let you actually have a class that emits its own code at compile time, then again, there are pieces that go into what's going on, but they're definitely way off the deep end fancy because we have code writing code at compile time, and that is not at all a trivial example of where most people are going to wind up using the language. So I've now yammered on for about an hour and 15 minutes. I've covered the content that I would like to, but are there any questions before we wrap up?
There are not at the moment.
Okay. Well, I'd like to thank all the North Dallas leadership for having me on and dealing with my smart aleck comments and making you characters in my narrative examples this evening.
We appreciate you coming and talking to us. And
we absolutely do.
Because I'm going to be famous now.
That's right. You're going to be checked into code. You're on GitHub.
I'm on GitHub. So yeah. Well, thank you, Tim.
Yes.
Any last questions? Anyone? You can unmute yourself if you would like. All right.
And you have about 10 people that have said thank you. So
You're very welcome. You're very welcome all. So I'm pushing the final code literally to this moment. It is now up on GitHub. So should you like to be able to examine it, by all means.
All right, cool.
So we do have a question.
Would you like, since you did volunteer to come speak for us, would you like to do a plug for Improving?
Of course. So Improving is a software consultancy and training company. We help companies throughout North America with their IT projects, large and small, from development of custom applications to, which is my specialty, to, hey, let's come in and do an implementation of Office 365 for our large enterprise or our small enterprise and try to get things off and running. If you need help with CRM, BizTalk, anything in the Microsoft space, we have you covered. Open source space, we have you covered. We're happy to work in Node and Ruby and Java and maybe somewhat Java. No, I'm kidding. Yeah, so we're happy to work in whatever languages that you're working in. And then I would also make one last plug for the fact that we are also one of the official sponsors of the Mass Transit Library, something that I've spoken about here in the past, and now are offering certification training for developers on mass transit. And if you go to that certification training, you're not going to be listening to me. So this is a major selling point. You are instead going to be listening to the much smarter than me, Michael Perry, who is our lead instructor on that initiative, and just an all-around great guy who's forgotten more about math than I ever knew. So yeah, that's Improving.
Thank you. And during this time, we have actually got a question in the chat. With how C# is evolving, do you think in a couple of years or sooner we will have monads as first-class citizens in C#?
Yes, I do think we're going to wind up there. I will tell you that the C# team has already responded to a bunch of questions and critiques, in particular around a lot of people loving the with syntax, and stressing that it is their intention to look at the whole of the type system and start moving the whole of the type system inside of the .NET ecosystem to supporting the with operator, so that you could automatically copy one object to another, and to get to the point where the overrides of equality and hash code just happen automatically. Now, lest you immediately pull your hair out and go, dear God, what would that do to our code? I am certain that much like the way they have implemented the concept of null checking into the language, where you have to opt in to that as a explicit check, then I would expect it to come that same way, that we're never going to change the default behavior of a class just as a class, but we will absolutely be able to get to a point where you can walk in and go, nope, for my new C# project, I am opting into all of my objects should follow this paradigm, and then they will.
All right. Well, thank you, Tim. Thanks, everybody, for coming. I believe next month, Amir Rajan will be talking to us. I believe he's giving us a deep dive on LLVM. I believe that is the plan. So looking forward to that. If anybody has any questions, feel free to put them in the general channel, in our site channel. And also, Russell did post a link to that. So please sign up, sign in, so we can all chat. So thanks for coming, everyone. We will see you virtually next month. Thanks again, Tim.
Thanks, Tim.
Thank you, Tim.